So first of all, I would like to thank the organizing committee for this very kind invitation. It's a pleasure for me to be here. I will speak about glucose metabolism and gut microbes also. The gut has been considered probably as a simple organ to digest food. And we have to take into account that, indeed, the gut is important to digest food, to provide us different nutrients, but we also have to take into account now that all these different nutrients may have an impact upon health, and that by choosing our foods, we can feed some microbes. So the food choices are really important to improve and to increase, for instance, some specific bacteria in the gut. It is considered that there is probably half of the cells that compose our body that in fact are microbes. If we do not take into account the red blood cells, it's even more. There are probably tenfold more microbial cells than on our human cells. But the most important point here is that those microbes are in fact encoding different genes. We always studied our specific physiology by splitting all the different systems, was for instance the muscles, the GI tract, but also the cardiovascular system and bones, but we have to take into account that all the cells in our body really dialogue together. So it is thought that the microbes may probably impact many systems and may probably also reduces the risk of different kind of diseases. Obesity is associated with a cluster of metabolic alterations that are associated, for instance, with change in glucose metabolism, glucose intolerance, insulin resistance, diabetes, but also cardiovascular diseases risk factors. And the common feature of the obesity and all these metabolic features is in fact this low-grade inflammatory tone. What means metabolic endotoxemia? In fact, we have in the gut bacteria that are gram-negative bacteria that harbor on the cells, on the membrane, lipopolysaccharides, LPS, that are really pro-inflammatory factors. And we discovered that a high-fat diet feeding and obesity, whatever the model, high-fat diet, but also genetic obesity, were associated with a small but significant increase in LPS. And this is what we call the metabolic endotoxemia. That stress, anxiety, sedentary, excess of alcohol, saturated fat, or the lack of prebiotics fibers, lack of fermented products, can contribute to this leaky gut, can contribute to this translocation of bacterial components into the blood and start to induce inflammation, fatty liver, and so on. And all these specific features contribute, in fact, to increases glycemia, to increases glucose intolerance and insulin resistance. Yes, we can indeed improve our health by eating some dairy products, but also yogurt. And there are now, I will just show you some examples, many papers, many meta-analyses, many reviews, and many analysis cohort studies showing that in, for instance, here, the ingestion of yogurt reduces the risk of type 2 diabetes. You see in another paper here, a 7-day food diary, and what they found is just the conclusion: a greater lower fat fermented dairy product intake, largely driven by yogurt intake, was associated with a decreased risk of type 2 diabetes development in prospective analysis. A recent paper, 2016, yogurt consumption is associated with lower body mass index, as mentioned and nicely reviewed by Dr. Tremblay, and also smaller waist circumference, lower body fat in all these different epidemiological studies. Also recent papers in elderly subjects. So elderly subjects, as you know, are also associated and they are more at risk of cardiovascular risk factors, but also risk of diseases, bowel. And there is a quite old paper now showing that yogurt consumption in elderly subjects may contribute to reduce this metabolic endotoxemia, may contribute, in fact, to reduce the plasma LPS. Before the consumption, you have the levels. After the consumption, you see this dramatic drop, suggesting again that by a simple ingestion of yogurt, they have improved probably the gut biofunction that finally reduces the risk of translocation of LPS. I highly recommend this review. I do not know really personally the authors, maybe one of the authors, but honestly, you have to read this because it clearly summarizes all the different mechanisms that may contribute to reduce type 2 diabetes and weight management following the yogurt consumption. And I've just showed you some relationship between the gut microbiota and the translocation of LPS, but there are also other probably mechanisms that merits to be discussed. And it's interesting just to keep in mind that we have receptors in our gut that can directly recognize the metabolites from the microbes, metabolites that will induce an increased secretion of GLP-1, and GLP-1 is a key hormone involved in the reduction of food intake, fat mass, but more importantly, in the reduction of glucose levels, improved insulin resistance. Just to summarize the different mechanisms, so you have here the gut bacteria, the gut health and the gut lining, you have the mucus, you have the bacteria, and you can, by using, for instance, yogurts, different type of yogurts, and also prebiotics, I will come to that later on, improve the reinforcement of the gut barrier, reducing metabolic endotoxemia and inflammation, and all these specific metabolic features will be associated with a lower insulin resistance and a lower glucose levels. At the end of the 90s, when Marcel Robert Froid discovered for the first time the concept of prebiotics. So the prebiotics, as you know, are in fact non-digestible carbohydrates that will be fermented by specific microbes in the gut that will also improve the production of some specific metabolites, but also bacteria, and finally will have a beneficial impact upon health. And for the next part and the final part of my talk, I will discuss with you about one bacteria. This is something that I discovered really by chance. We found that the prebiotics do increase bifidobacteria, of course, it was known, but also profoundly affect the microbiota by changing or at least 100 different bacteria. So it's a very complex modification. And if I make a parallel with yogurt, you know that some yogurts may also contain prebiotics. And in fact, when you are eating the bacteria, plus the prebiotics, you have probably a very strong modification of the microbiota towards beneficial microbes. And among the bacteria that we found, that was this Akkermansia mucinifera. It's in fact, it's a gram-negative, so I was really surprised because, as I told you before, the gram-negative bacteria, they harbor LPS, and we were thinking about the fact that increasing gram-negative bacteria might be deleterious, and it's probably not really the case. Here, in fact, the gram-negative bacteria, Akkermansia, is associated with a healthy situation. Because when you have this higher amount of Akkermansia, there is a lower level of plasma LPS. So, in other words, an inverse relationship between the LPS and Akkermansia, an inverse relationship between the amount of specific macrophage, so immune cells into the adipose tissue, and Akkermansia. During the thesis of Hubert Plovier, we published a study showing that we can use Akkermansia pasteurized, so we stabilize the bacteria, and stabilizing the bacteria or some specific proteins isolated from the bacteria can improve diabetes and reduce obesity. In general, what we think is that if you take care about the gut microbes by using even yogurt, polyphenols that will be discussed with André in the next talk, you can reinforce the gut barrier. And if you reinforce the gut barrier, you avoid the slow-grade inflammatory tone, and you maintain a good homeostasis, a good balance between the glucose metabolism, lipid metabolism, energy metabolism, and so on. So I would like to thank, all the different colleagues and all the different contributors and the financial support, all the team in the lab, and you for your attention, and think about this.